Water use. In traditional assessment of water available from human use, renewable available fresh water is considered to be non-blood stage stream flow and reservoir storage. Table 5.2. Estimate use does not include rainwater that falls on the earth only to be transferred by crop plants and groundwater from wells. This produce is follow her because rainwater used by crops would have been evaporated or transferred had not crop been involved, and because removal of groundwater by well lowers the water table and lessens the amount of ground water base flow, contributing to non-blood stage flow of stream. Consumptive water used by human, the traditional being calculated as surface water floods, groundwater from well done evaporate as a result of each use. There is, however, a recent tendency to divide water use into their categories. Green water is rainwater that evaporates during this water is used almost entire from agriculture. It would have evaporate anyways. Moreover, green water is not including in estimate of renewable able fresh water. Blue water is surface water or groundwater that evaporates during use. Blue water is basically the same as traditional consumptive water use, and it can be calculated with reasonable accuracy. Gray water is the amount of water needed to treat the waste resulting from water use. Its term of water use to use. Ito yung isa sa mga problemang groundwater from well, green water, blue water, and gray water. Kunti lang ang water resources natin kaya kailangan i-manage. There is no objective way of estimating gray water, therefore we do not reporting adoption of total water use summation of green, blue, and gray water as a means of assessing water use for agriculture and aquaculture. Estimating of major consumptive uses of water show that agriculture is the major consumer, accounting for more than 80% total global water use. Consumptive water used by agriculture amount to 30% of available renewable fresh water. Nevertheless, water supply is not distributed in accordance with population density, and arid region with high population densities often have a natural scarcity of fresh water. Even in some areas where water is normally plentiful, water shortage may develop during period of through some countries do not have adequate water distribution infrastructure or suffer from political unrest of armed conflict that with water distribution, water pollution by also make water unstable from some uses. Consumptive water used in freshwater aquaculture fund average about 1 million. Ay, teka. There are several ways of reducing the directly of use freshwater is fund aquaculture to include production intensification, water use contraction techniques to minimize seepage loss and water level control to capture as much rainfall as possible, increasing production from 300 kg HA to 600,000 kgHA in a fund with an annual water use of This produce does not usually conserve water because the combined area from production and waste treatment equals that a non-partition pond with the same amount of production seepage loss can be as much as 50 cm MO or more in funds, but seepage rate usual can be reduced to 10 to 20 cm MO or less by proper seeding and construction practice. Rainfall can be captured by maintaining water level is found to 10 to 15 cm below overflow levels. Capture rainfall partially offset the future need for found water from other sources. Water exchange is a particularly fun practice that seldom improves water quality is large aquaculture fund, but it increases water use and population potential aquaculture facilities. Mechanical aeration is not affected than water exchange is maintaining adequate DO concentration in fund. Mechanic aeration, especially those not expand water into the air by increasing water loss by exposing more water surface area to air, but is those not increasing water use as much as those water exchange. Verification kung kayang i-verify done better. Figure 5.8 shrimp farming, which a energy use. The water use a tremendous amount of energy from industry, agriculture, transportation, domestic and municipal activities, and other purposes. The total global consumption of primary fuels was about 541 times 1018 or 541. In 2014, only about 60% of this energy is end-use energy. The remainder is consumed in transforming the energy in the primary to energy use from a specific purpose. In 2008, end-use consumption of energy for all purposes was estimated to be used in the World Fund system. Most of this energy was used for processing, distributing, retailing, preparation, and looking table 5.4. The share for production of the food at the farm gate or dock in case of capture fisheries was only 21.4% of total energy used in blood system. In FAO Report 2011 using data for 2008, estimating energy used for a capture fishery to be, which is rather large considering the energy used for all terrestrial animals production accounted from only 5.1. In the same report, aquaculture was estimated to use only 0.4, much less than need capture fisheries. However, few studies of energy use in aquaculture have been made, and the FAO estimate appears to low. Several life cycle analyze LCAS of aquaculture production of tilapia, canal, catfish, salmon, shrimp, and mussel give a average total energy use of 26 aquaculture production in 2008. The year of the FAO report was 53, given an overall energy use to aquaculture of 1.4. However, almost no data are available from production of species ratios lower energy input such as certain types of crop aquaculture, so there is considerable uncertainty regarding overall energy use. About the best that can be said is that energy use in aquaculture was probably somewhere between 0.4 and 1.4 in 2008. There are several direct use of energy in aquaculture, which include facility construction, pumping, water aeration, and farm operation. Considerable energy is also used in producing feedstuff, manufacture feed, and delivering into farm. Figure 5.9 shows indirectly energy used in often called employed energy, and the energy content of aquaculture feed range from around 4 to 10. Aeration is also a major energy input to aquaculture. For example, an aeration rate of 1.5 of production and 1,000 hours of aeration during a crop consumption of electricity would be CA 5.4 of production. Facility construction can be over several years and will be seldom be greater than 2.0 of production energy. To pump water for feeding funds and replacing evaporation and seepage loss usually will not exceed. Energy conservation is important because most energy used in aquaculture is from non-renewable resources. The combustion of fuels is also a major source of greenhouse gases that contribute to global climate change. 5.6 Feed fish use. Fish and other aquatic organisms are capable of converting protein in their feed to edible animals protein with good efficiency. So, mataas ang feed conversion efficiency natin compared with other livestock. In poultry, mas mataas pa rin ang ating feed conversion ratio. The percentage of feed protein covered in harvest biomass and in processed pills for 5 common species average to 30.9% and 19.4% respectively. Depende na lang kung siya ay carnivores, omnivores, herbivores, as much as possible kung kaya nating mas alagaan ng mga as close to the primary producer, the better. Kung sila ay herbivores or omnivores, the better. Kasi kapag nag-carnivores ka, magiging mas marami ang problema mo kaysa kailangan mo ng mataas na protein content. Compared to terrestrial meat, animals, aquatic species generally need somewhat higher protein concentration is their feed and says are not great. Naylor rate 2009, but they tend to have better feed conversion efficiently than terrestrial animals. Aquaculture species vary greatly with respect to feed protein conversion, and some species are superior with others are inferior to floral chicken. In this regard, however, aquaculture species use convert protein more efficiently than to swine and of beef cattle. Production of aquaculture animals appears to be at least as efficient as traditional meat animals is converting feed ingredients and feed protein is particular to meat and animals protein for human consumption. Of course, the production of aquaculture species much less than that of traditional meat animals. The Altech 2015 Global Feed Survey revealed that the total global production of animals feed in 2014 has 980 million. Animals feed consumption by species categories was as follows: poultry 439 million to 256 million, cattle and other ruminants 196 million, and aquaculture and 41 million pets and 22 million equines with 11 millions. The major difference is aquaculture feeds and other animal feeds is that a large amount of fish meal and fish oil is included in fish from some aquaculture species, especially in feed for marine shrimp and carnivores. Fish as straw and salmon fish meal is included in aquaculture feed fish. It is high protein content with balanced amount of amino acid and also contain phosphorus, calcium, and essential omega fatty acid. Fish oil has a higher ratio of 3 to 6 fatty acid, and this high ratio is considered to be beneficial to human cardiac health. Vegetable oil have a lower ratio of 3 to 6 fatty acid and is widely believed that inclusion of fish oil is aquaculture diet enhanced than a 3 to 6 fatty acid ratio to meat of aquaculture species. Fish meal production from the capture of the pelagic fish, herring, menhaden, anchovies, herrings, sardines, and other still kailangan. So, ang culminate niyan ay yung ipapakain mo para sa culture na kakainin mo rin. Ibig sabihin, kung kaya mo na ang ipakain mo ay bioduct, para hindi kasi ang chubby ay pwede nang kainin ng tao. Yun yung issue ng fish feed use. Other source of fish meal and fish oil. Madali nang gamitin sa tao, mataas pa rin ang ratio ng omega-3 at omega-6 fatty acid. Kailangan pa rin alisin kapag nagpapakain ka sa aquaculture species. Ang mas maganda na ang fish oil ay galing pa rin sa isda because of the omega-6 and omega-3 fatty acid. Kaya tayo kumain ng mga isda sa dagat dahil mayaman sila sa fish oil, omega-3 at omega fatty acid. For aquaculture, feed is trash fish of bycatch consisting of aquatic organism captured through net that do not have a market volume for direct human consumption. Troll fishing has been acknowledged as a destructive practice, but is the traditional means of fishing is many parts of the world. Bycatch watch was once considered relatively useless, but in certain areas has gained a market as a feed component for aquaculture. As unfortunately consequence use of bycatch for aquaculture fish foster the indiscriminate catch of any species, because large or small there are no market for this previous volume product. The capture of pelagic fish and bycatch to produce fish meal and fish oil can affect biodiversity. Is the ocean overfishing of these fisheries could be passed through the food chain to cause a reduction in production of some omnivores of carnivore species important in the fishery. For human consumption, there is a limited supply of fish meal oil that could restrict the future production of aquaculture, especially those species for which feed contain a high percent of fish meal and fish oil. Using wild-caught fish is aquaculture feed is perhaps the most significant environmental impact of aquaculture, or at least the most discussed. Most other environmental impact of aquaculture are localized, so-called near-field effect, widely understood and often reversible with simple change in manage of technology. The concern with feed fish use is aquaculture is global, with farm-reaching implication. Farm field effect. The worrisome concept is that farming fish and crustaceans on feed containing high level of fish meal and fish oil, those not increasing global fish production. In other words, each kilogram of farm fish consume more than 1 kilogram of feed fish in the form of fish or fish oil. The amount of feed fish needed to grow a kilogram of fish of crustacean is aquaculture is called the fish in fish of out ratio and is calculated from the FCR. The percentage of fish meal and fish oil is the feed, and the ratio of the quantity of feed fish required to produce a unit of fish meal or fish oil. Receive diet with high inclusion rate of fish meal and oil. Several kilograms of fish by be required to grow 1 kilogram of farm fish. For fish receive diet with low levels and fish meal and fish oil, from less than 1 kilogram of feed fish and needed to grow 1 kilogram of farm fish. One of the point of concern is that it appears to be ecologically inefficient when fish are fed diet with high level of fish meal. Most fish caught for reduction to fish meal and oil are not commonly used as human food. Using the meal and oil fish animal feed add volume. The apparent ecological inefficiency of the process is also misleading, because efficiently are inevitable and natural when organisms in one trophic level consume biomass from a lower trophic level. In fact, the efficiency of food use in aquaculture is considerable. better than in natural, where ecological efficiencies are on the order of 10 flood or for each change in trophic level. Increasing demand for fish meal and fish oil has caused dramatic increases in price since 2000, increase caused